in origin, about 50 kilometers in circumference, and with a population of over 10,000 people, earning their livelihood in agriculture or by fishing. Through the centuries, people of Hachijo had suffered from a strange fever that struck only in the winter months. The disease is characterized by a rash over the entire body and the presence of a small ulcer or eschar. This is the eschar. This rickettsial disease, similar to Tsutsugamushi disease or scrub typhus, was found to be transmitted by chiggers or larval mites of the species Trombuiculidae. Here a chigger or larval mite is shown crawling along a human hair. The mite is 1/10 of a millimeter in size. Here you see a typical temperature chart of a patient. A dramatic drop in temperature follows initiation of drug therapy with antibiotics such as the tetracyclines or chloramphenicol. The story does not end here, however. With the successful treatment of the disease, the observations of an island physician led to some very interesting studies of the sensory physiology of the chiggers. In pursuing his interest in the epidemiology of this disease, the physician trapped rodents and collected ectoparasites. On his way to visit patients, he often placed out traps in suitable habitats. Chiggers are found in great numbers in the outer ear of rodents. A bird, Detritus selenops, which is peculiar to the island, also serves as a host for Trombuiculidae. The physician was not satisfied merely to find the chiggers on rodents. He searched for their habitat apart from animal hosts. Careful, painstaking search revealed many mites on the tops of stones and rocks. After many observations, the physician discovered that the mites were in cracks and crevices of the rock and came out on the surface of the rock soon after he came on the scene. He also observed that mites would come out on the surface of rocks for about 2 meters around himself. How did the mites learn of his presence? The physician discussed his observations with the scientists from Tokyo University. They confirmed his field observations and took up the challenge. In order to permit further studies in the laboratory, mites are collected in test tubes by a member of the team from Tokyo University. The mites are brought into the university laboratory in Tokyo. The scientists, individually and collectively in their discussions, speculate on the trigger mechanism that brings the mites out of their niches and the nature of the stimulus for their agitated activity. Naturally occurring rocks are too irregular to permit simple controlled experiments, so the group proceeds with laboratory methods to devise a suitable stage. They decide on a simple cone made of powdered charcoal and plaster of Paris. Mites are released on the inverted, hardened cone. The mites on the surface of the cone with their general orientation towards the top. After about 20, the mites are gathered near the top of the cone and on the side away from the light. The mites respond negatively to two geotaxis and phototaxis in seeking their resting place. That is, they respond negatively to gravity and to light. When the cover of the dish is removed, the mites begin to move about in an agitated manner. What stimulates the mites? The scientists recognized two obvious possibilities: sound or vibrations and changes in light intensity could be the stimuli. Could mites hear or feel vibrations created by an approaching host? Also, a host would cast a shadow, and perhaps the mites were sensitive to changes in light intensity. Tests were designed to determine the effect of various stimuli. Mites are released onto a cone, which is placed in a special chamber. Observations are made through a small window. The mites in the chamber are nearly completely isolated from extraneous environmental factors. Leaves are rustled. No reaction. Hands are clapped. The mites remain quiet and indifferent. Light intensity is varied with little apparent effect. Strong illumination causes some mites to move slightly. Body odor is tried. A wad of cotton, which has been held close to the body, is placed in the funnel. Again, there is no reaction. Next, human breath is introduced into the chamber through a tube. There is an immediate, strong reaction. What could be the stimulus in exhalant breath? A measured amount of breath is taken up in a syringe and forced into the chamber to see if it is adequate to stimulate the mites. The mites react strongly. The group decide to try selective absorption with various chemicals to see if by elimination they can pinpoint the stimulus. First, breath is shaken in a syringe with soda-lime solution. The soda-lime solution is discharged and the remaining air is injected into the chamber. There is no reaction. The stimulus has been removed by absorption in the soda-lime bath. The stimulating component of exhaled breath is absorbed by alkali. Carbon dioxide is absorbed by passage through alkali baths. Human breath contains approximately 4% carbon dioxide. Carbon dioxide is produced artificially by adding sodium bicarbonate to dilute HCl. The gas is accumulated in a polyethylene bag. The gas is taken up in a syringe and introduced into the chamber. The mites are stimulated to frenzied activity by carbon dioxide. The effect of carbon dioxide on fleas is also interesting. Fleas usually remain dormant in cracks, crevices, in sand, or in the soil. Here in the laboratory, dog fleas are collected in a flask with sand and pieces of paper in the bottom. Gradually, the fleas quiet. Sounds or vibrations produced by rapping forceps against the flask do not cause the fleas to jump. But when a person's breath is blown into the flask, the fleas suddenly become active. The pinging noises are the fleas hitting the sides of the flask when they jump. In the absence of man or other animals, such as in a summer house, fleas stay quiescent in cracks and crevices. Thus they can conserve their energy and moisture for long periods of time. When people or animals return, the fleas are alerted by the increased carbon dioxide in the air. The fleas are awakened and begin to jump in search of the host. Carbon dioxide serves as a dinner bell for the fleas. Mosquitoes are often serious pests in the summer season. They feed on our blood, cause itchy bites, and sometimes transmit agents of disease to us. This is the yellow fever mosquito piercing the skin of a woman. To demonstrate the effect of carbon dioxide on mosquitoes, a piece of dry ice is placed on a cemetery stone in which there is a hole containing resting mosquitoes. The cool, heavy carbon dioxide coming from the dry ice falls or flows into the hole. You can see the mosquitoes emerge from the hole. Some female mosquitoes, apparently deceived, are stimulated to feed and appear to be trying to pierce the stone. Male mosquitoes do not feed upon blood and do not appear to be stimulated by carbon dioxide. Recently, the team of scientists discovered another surprising effect of carbon dioxide. The infective young of hookworms react electrically to carbon dioxide. Wherever night soil is used as a fertilizer, hookworm eggs may be broadcast over the land. The young worms hatch and invade human beings, usually through the skin of bare feet. The adult hookworms inhabit the intestines of man, sucking blood from the mucosa. Hookworms infest a great many people in tropical and subtropical areas of the world. About 20% of the farmers of southern Japan are infected with hookworms. The Japanese scientists experienced some difficulty in isolating the young worms to test their reaction to carbon dioxide. A modification of the plaster of Paris cone proved very satisfactory. The tip of the cone was removed and a cone-shaped depression made, somewhat like a miniature volcano. Young hookworms are cultured in test tubes. They are collected by pipette and dropped into the depression of the cone. The worms move gradually upwards, and when the cone is kept in a chamber away from distracting environmental influences, the young worms become relatively quiet. Some stand out from the surface like needles. Others form clusters that sometimes look like cords of many fibers. When breath is blown into the chamber, the young worms begin to writhe in a dance macabre. On a little out-of-the-way island, the persistence and remarkable observational powers of a country doctor led to a clearer establishment of carbon dioxide as a potent stimulus to parasitic animals.